Welcome to Study Loop.
Problem 8.79, we have a bullet, little b, hitting a block, big B, that's attached to a spring. We're told the masses of these things, which conveniently enough add up to 1 kilogram. And we're told that the spring exerts a force of 0.75 newtons when it's compressed 1/4 of a centimeter. So, and we're told that the block compresses the spring by 15 centimeters after the impact. The maximum amount it compresses it is 15 centimeters. So we want to figure out how fast the block with the bullet is moving right after the impact. And then we want to figure out how fast the bullet was going to begin with. So let's get started. This first one is going to be a conservation of energy issue. First, we need to figure out what the spring constant is, which is easy enough. It's F divided by X. We use our 3/4 of a Newton and our 1/4 of a centimeter. Remember to convert centimeters to meters, or you can convert newtons to centinewtons. Either way, you want to have the units right. And so this has a spring constant of 300 newtons per meter. Now, from conservation of energy, we know that the potential energy in the spring when it's fully compressed and the block is stationary momentarily has to be equal to the kinetic energy of the block with the bullet embedded in it right before it starts, right at the moment of impact and right before it starts compressing the spring. So our speed here is going to be x times the square root of k over the combined mass. And this gives us 2.60 meters per second. So far, so good. Now we want to use the conservation of momentum. We know what the speed was of the combined thing, so the mass of the bullet times the bullet's speed before the impact has to equal the mass of the block and the bullet combined times the speed after the impact. So, speed of the bullet is going to be equal to the ratio of the two masses times the speed it was going after the impact. And this ends up being 325 meters per second.